Sorry that the video just now cut off early. So let's continue. So basically from this particular index law, what we can do next is to substitute, for example, a to the power of m is x, and then a to the power of n is y. So x multiplied with y equals to a to the power of m plus n. Okay, so then we can apply the definition of logarithm. Then what we have is log base a xy equals to m plus n. And m, just now we already wrote it over here. M is log base a x, n is log base a y, and there we have it. We basically show this particular identity. So the next law of logarithm is basically x divided by y. Sorry. So you will have log base a x minus log base a y. The way to derive this identity basically is the same as above. It's just that now we are using this particular expression. So if you want to, you can do it by yourself. So the next one is log a b to the power of m equals to m log base a b. So how do we prove this? The beginning one is using this particular law of index. So what we need to use is a power m n equals to, for this demonstration, we switch up the position of n and m. So we use this. So we let a to the power of n equals to b, for example. Then by definition, log base a b equals to n. So a to the power of n is b. So from the identity above, b to the power of m is a m n. Then we apply the definition of logarithm. What we will have is log base a b to the power of m will be equals to m times n. So we know what is the value of n, and that would be m log base a b. So we recover that particular expression as shown. So the last one, this is what we call as the change of base formula. If you have log base a b, what you will have after you change your base, for example, you change it to c, that will be log base cb divided by log base ca. So this is what we call as the change of base formula. So how, wait, sorry, I should use the blue. So how do we prove this? So we can let, For example, a to the power of x equals to b. Then by definition again, log base a b equals to x. Probably we can just stick to m because I mean it depends on how you would define it. Usually we define this way, like basically what we did on top is like that. So we can use m for example. So then so from this particular definition, we take logarithm on both sides. Particularly, you want to take log base c. So once you did that, you have log base c a power m equals to log base c b. So this particular expression on the left hand side, previously we already showed that it will be equals to this one. The index of b you move in front. So in this case, this would be m log base ca equals to log base cb. So m would be equals to log base cb divided by log base ca. So what is m? m is log ab. So therefore this is log base ab. That's how we prove this particular law of logarithm, which is called the change of base. So that's for the properties of indices and logarithms. So now let's look at their graphs. So part C. So if let's say you have, for example, y equals to a power x, and a is greater than 1, then the graph that you have will be like this. So over here is when your x equals to 0. So this has to be sorry, over here your x is 0, so this should be 0, 1. Okay. So what else? So if let's say the same thing, y equals to a power x, and your a is between 0 and 1. Sorry, this is a. Then what you need to do is to sort of like mirror it with respect to your y-axis. Like that. So over here, this is also 0, 1. So why is that so? Because when let's say why is that the mirror image at reflection on your y-axis? Because let's say you have y equals to a power x, and your a is between 0 and 1. So this corresponds to y equals to 1 over, let's say a equals to 1 over b, and b is greater than 1. Okay. So this will be equals to b to the power of minus x by using the index law. And this particular negative sign is what we have studied based on the function transformation when b is minus 1, number 6, which is a reflection about y-axis over here. So that's why when a is between 0 and 1, basically it is a reflection on your y-axis. So that's the reason. So we note that so this is important. We note that the logarithm function is the inverse function of your exponential function. So what does this mean? This means that the graph of your logarithm basically is a reflection of your exponential function at y equals to x. So then you can sort of like sketch the graph for y equals to log base a x. So of course you can divide into two graphs. So if your a is greater than 1, the graph will look like this. Sorry, let me draw it properly. The graph will look like this. If your a is between 0 and 1, so once you reflect it on y equals to x, it would then look like this. Okay? So that would be your shape of graph for logarithms. So of course, coming from the graphs, you also need to be able to identify the domain and the range. So for this, we can sort of like draw a table. So let's say this is y equals to a power x. And let's say this is y equals to log base a x. So let's say this is your domain and this is your range. So for domain, your exponential function basically it will be the set of all r. For range, this will be y greater than 0, as you can see from the graph. So for the logarithm, it will be the opposite. Domain will be x has to be positive. Range will be the set of all real numbers. So these are the domain and the range for logarithm function. So that's probably it for exponential logarithm function. we now cover the last functions, which are quite important as well, called the trigonometric functions. So for trigonometric function, basically what you need to know is the definition of sine, cos, and tangent. So let's say this is a right angle triangle. And let's say this is B, C. And this is my angle. So the definition for sine theta would be B divided by C. Definition for cos theta would be A divided by C. And the definition of tangent of theta would be B divided by A. So these are the definition of sine, cos, and tangent. And then from the definition of tangent of theta, B divided by A is also equals to B divided by C, and then divide by A divided by C. So if you perform the calculation, you will know that this is true. So in short, tangent theta is also equals to sine theta divided by cos theta. So the next thing is that from Pythagoras theorem, we know that A square plus B square equals to C square. So what you can do is to divide everything by C square. You will get A divided by C square plus B divided by C square equals to 1. So A divided by C is cos. So cos square theta plus B divided by C is sine. Sine square theta equals to 1. So this is another definition that you need to know. And then what you need to know is also how to convert from radian to degree and from degree to radian. So all these are very important. So the next important point is, if let's say you have some degree, you want to change to radian. So basically you take the theta degree, multiply with pi divided by 180, then you get your radian. And conversely, if you have the radian, you just multiply with 180 divided by pi, then you get back your degree. So those are the conversion factor. Then the next thing that you need to know is the signs for trigonometric functions. So these are sort of revision from probably what you have learned before you enter the preview mathematics. So I will go slightly faster. So for the first quadrant, your sine, okay, let's just put A, because your sine, cos, and tangent will be positive. So this is the first quadrant. For the second quadrant, your sine will be positive. For your third quadrant, tangent will be positive. And for your fourth quadrant, your cos is positive. So you need to know this as well. And you also need to know how to count your angle. So the angle always begin from the first quadrant counterclockwise to second, third, and fourth quadrant. So these are all the definitions. So then the next thing that you need to know is probably how to get the sort of like special angles. Probably you don't really need it, but it is good for you to know. So let's begin with this type of right angle triangle, whereby the sides are equal, meaning that this will be 45 degree, and 45 degree you can convert it to radian. So that would be 45 divided by 180 pi over 4. So this is also pi over 4. So we can identify, let's say both sides has length 1. So the longer side will be square root of 2. So then let's use the definition. Sine pi over 4 sine pi over 4 will be 1 over square root 2, and 1 over square root 2 you can move the third to the top by multiplying square root 2 divided by square root 2. So this is also similar to square root 2 over 2. Cos pi over 4, it is the same thing. This is equals to square root 2 over 2. Tangent pi over 4, so that will be equals to 1. So now let's look at another type of triangle. I have to draw this in larger. Whereby the three sides are equal. Then you can extend this at the bottom. So if these three sides are equal, it means that all the sides are 60 degree. So this will be pi over 3. And this particular line will divide it, so it will become 30 degree. So that will be pi over 6. So, okay, let's decide some lengths. So let's say this is 2, this is 2, and this particular length will divide both. So left is 1, right is 1. So then the particular height will be 2 square root of 2 square minus 1. So it will be square root 3. Okay, so by definition, sine pi over 3 would be square root 3 over 2. Cos pi over 3 cos pi over 3 will be 1 over 2. And then tangent of pi over 3 will be square root 3. So sine pi over 6 will be 1 over 2. Cos pi over 6 sorry, the reason why I need to keep this particular writing in a better way is because later on I might want to upload it into the Google Drive. So cos pi over 6 will be square root 3 over 2. Sorry, cos pi over 6 is square root 3 over 2. So tangent pi over 6 would be 1 over square root 3, which is also equals to square root 3 over 3. So then you can sort of like compile all the list of special angles that you have over here. So those are the very basic fundamentals that you should know by now. So now we look at the graphs. For a sine graph, y equals to sine of x. We usually draw it like this. So this is 0. Over here, this will be pi over 2. This will be pi. Here will be 3 pi over 2. And then over here is 2 pi. And they correspond to 1. Here correspond to minus 1. So you can list down the domain of sine x and the range of sine x. So when we list down the domain and the range of a sine and a cos and tangent, for example, we want to make sure that that particular domain also contains the inverse. So usually for sine x, what we would do is to take from minus pi over 2 up to pi over 2. Because if you take a larger domain, your horizontal test will fail and you won't get the inverse. So for the range, then it will be from minus 1 to 1. So that is for sine x. For cos x, the graph will be like this. So over here, this corresponds to 2 pi. This is 3 pi over 2. Here is pi. Here is pi over 2. And then this is 1. This corresponds to minus 1. So similarly, when we list down the domain and the range, we want to make sure that the particular domain that we choose contains the allow us to define what is called the inverse. So from here, in this case, what we are choosing usually is from 0 to pi. Then your range will be from -1 to 1. So now let's look at the tangent graph. Tangent graph will be a little bit special. So this is pi over 2. You have some horizontal lines that you can never cross for the particular graph. So those, sorry, not horizontal, but vertical. So those lines are what we call as the asymptotes. So this is pi, this is 3 pi over 2, and then this is 2 pi. So we will talk more about the asymptotes in the next chapter. So for tangent graph, the domain will be from minus pi over 2. Because of the asymptotes, you cannot put the equal sign. It's from -2 to pi over 2. For the range, that will be the set of all real numbers. So mostly that will be it for all the special functions. Just remember, starting from polynomials and especially the quadratic equation, you need to be very clear about it. And then the exponential logarithm functions, all the properties and their graphs, domain and range. Finally, the trigonometric functions, need to remember all these special identities and their graphs. So that's it for today's video. So we basically sort of like accidentally divided into 2 videos because of my laptop stopping suddenly. So yeah, that's it. Thank you.